So this is Chapter 7, Section 1. Now we've already gone over this section in class, but I'll be re-recording the notes for this, especially for the STC course, because we will be having a test over Chapter 7, Sections 1 through 4. So I'll be posting up a video of the notes as I take them, and we'll start with Section 1. So that way you guys can have them available for study and to look back at them and whatever, and be able to pause them and all that stuff. So, fundamental identities. Now, first off, we defined a trigonometric identity. So this is just the word identity. And that's just an equation that is satisfied by every value in the domain of its variable. So in this case, we're talking about trigonometric identities, and the variables in question are angles. So angles are real numbers, and in this case, we don't limit them. They take on any value from negative infinity to positive infinity. So first few identities, the reciprocal identities. And there are three major ones. Cotangent is equal to the reciprocal of tangent, so we write 1 over tangent. So the way that we write a reciprocal, one way we write a reciprocal in algebra is to write it as a fraction, and it's 1 over the quantity that it's the reciprocal of. Secant, same thing, it's 1 over, in this case, cosine. Cosecant, 1 over sine. Okay. Quotient identities. Tangent is, if you remember, sine divided by cosine. Cotangent is the reciprocal of tangent, so it's cosine over sine. Pythagorean identities. I'm trying to go through these quickly because we've already seen these before. So sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. 1 plus cotangent squared is cosecant squared. And of course, I'm writing theta, theta, theta all the way throughout. These only work if those are the same angles. Tangent squared theta, secant squared theta, cotangent squared theta, cosecant squared theta, sine squared theta, cosine squared theta, and so on. Even odd identities, the way to remember this, the only two functions out of the 6 that are even are cosine and secant. And these are reciprocal pairs, cosine and secant. So cosine and secant are the only even ones. Even means that when you negate its argument, the inside stuff, negative theta, it doesn't feel it, and it's as if it had never happened. Cosine theta. This one's secant theta. So negating the inside, negating the angle, will not change anything. Sine, cosecant, tangent, cotangent, those are odd functions, and what they do feel is the same thing as if you had negated the outside. And I'm writing secant, that's not secant, that's sine. So negative sine theta, cosecant negative theta is negative cosecant theta. Tangent negative theta is negative tangent theta. And then cotangent negative theta is negative cotangent theta. So those are the even odd identities. So if I remember, I don't even think we use these identities, the even odd identities, that is, maybe in one little place in this particular section. Well, let's see. A note here. There are alternative ways to write the first Pythagorean identity. The first Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1. Or not in that order. It could be a different order. You can switch the order. Sine squared and cosine squared, not a big deal. What we can also do is move them over by subtraction. So if you wanted to have sine squared isolated, you would subtract cosine squared on both sides. You would get sine squared is equal to 1 minus cosine squared theta. And there's the other form. Cosine squared theta, if you wanted that one isolated, 1 minus sine squared theta. Now, something else that we can do, if you wanted to come up with an expression for just sine in terms of cosine, or the other way around, you would square root both sides. And sine theta technically is equal to, you square root both sides, and whenever we square root both sides, you get a plus or minus as a result. Square root 1 minus cosine squared theta. So these two are basically the same thing by the, I forget what that is, the power property or the square root property, one of those two. Cosine squared theta, if you square root both sides, you get cosine theta. Equals to, same thing, plus or minus a square root quantity. In this case, it's 1 minus sine squared theta. And these two are basically the same thing. Now, you can determine the sign, whether it's positive or negative, in front of that square root. So that positive or negative, we can choose and determine how to choose which of those two apply, depending on the value of theta. The value of theta tells me what quadrant theta is in. And once we know what quadrant theta is in, you can choose accordingly, positive or negative. Remember that in the first quadrant, sine is positive, cosine is also positive. Second quadrant, sine is positive, cosine is negative. Third quadrant, they're both negative. Fourth quadrant, sine's negative, cosine's positive. Okay, so we'll move on. Example 1. So here's an example of how to use these identities if we're given some information about theta, and they want all the rest of the information for theta. So in this case, what they're giving us is cosine theta is equal to 5/8. Theta is in quadrant 4, and they want us to find this information: A, sine theta, B, tangent theta, C, secant of negative theta, which, by the way, we just went over these. Secant negative theta, and this is literally the only place in the entire section where they apply the even odd identities. Secant is even. So therefore, secant of negative theta is the same thing as secant theta. Okay, so for letter A, we want sine theta. They gave us cosine, and they told us the quadrant. So that goes back to what we were talking about here. So they gave me cosine. I want to find sine, and I know what quadrant it's in. So I can use one of these two formulas to determine the value of the one that I want. So they want sine given cosine. I'm using this first one. So I could plug in the value of cosine into cosine squared, do the appropriate math, pick the sign depending on the quadrant they gave me, and that's going to be the value for sine. So I'm going to directly copy that down into the stuff for part A. See if I can remember it. Sine theta is equal to, according to the property, plus or minus, so positive or negative, square root 1 minus cosine squared theta. And I can directly plug in the value of cosine. And before I do that, I can choose the positive or the negative. So let's see how this works. Let me just change the color real quick. So we can choose either it's positive or negative, and it's in quadrant 4. And because we're in quadrant 4, if we remember, sine is negative, cosine's positive. So we're trying to evaluate the value of sine. Sine in quadrant 4 is negative. I'm ignoring the positive then. So we're only looking at the negative sign. So it's going to be negative whatever that square root reduces to. So it's negative square root 1 minus cosine squared of theta. Cosine of theta is 5/8. So if I want cosine squared, you take the value 5/8 and you square that quantity. So I want the square of 5/8. And when you square a fraction, of course, you square the top, you square the bottom, so the numerator and the denominator both get squared. That's a power property for exponentiation. You can distribute the exponent to both individual parts of the fraction. So this is negative square root 1 minus, that would be what, 25 over 64, being subtracted from the 1 underneath the square root, and that's going to be negated. So then I got to simplify 1 minus 25 over 64. In order to do that, or to simplify this, I'd need to combine those two quantities, 1 and 25 over 64. So I'd want to think of the 1 as a fraction. And in order for me to be able to combine fractions properly, you would want them to have the same denominator. So 1's an easy case. 1 doesn't show a denominator. You can assume a denominator of 1. And you have 1 over 1 equals to 1. And if I want the same denominator, I could just use what the other denominator is. The other denominator is 64. So I can rewrite 1 as 64 divided by 64, because 64 divided by 64 is equal to 1. So then I get negative square root. And I wrote the 1 again. Whoops. 64 over 64 minus 25 over 64. Square root of that. And then to subtract those two fractions, so 64 over 64 minus 25 over 64, you would subtract the two denominators. The two numerators and not the denominators. You leave the denominators the same. So this would be negative square root 64 minus 25 all over 64. So I'll write the 64. Let me see if I could just figure out 64 minus 25, 39. Now, for something like this, negative square root of 39 over 64, you have a fraction inside of a square root, and there's another property for square roots, which is similar to the property that we used for the square earlier. The 5/8 squared turned out to be 25 over 64. Something very similar can happen here. If you remember, a square root is the same thing as a power of 1/2. So you can think of a square root as a power, and you can either distribute that power to both parts of a fraction, or you can go backwards. But in this case, we would distribute the power to both parts of the fraction. What that means is you can square root both individual pieces of that fraction, and it's the same thing. So this is negative square root 39 only, and then we're going to write in the denominator. Square root does not apply to the denominator in this case anymore. If you evaluate the square root of 64, it ends up becoming 8, and that's what I mean by it's no longer a part of the fraction. Because then we've evaluated the square root of 64, it's equal to 8, and you can write 8 in the bottom. And I think that's as far as we can take it. This is the value of sine of theta. Negative again because it was in the what? The fourth quadrant. And then we got a square root because we were applying a square root property that came from the Pythagorean identity. The first Pythagorean identity, sine squared plus cosine squared is equal to 1. In order to solve, you'd have to take a square root on both sides. And that's what we ended up getting. And of course, I don't know if you see that. When taking the square root, be sure to choose the sign based on the quadrant. So I'll go ahead and write that in. Quadrant of theta and the function being evaluated. Sine in quadrant 4 is negative, therefore we chose the negative, not the positive. We ignored the positive one. So that's example 1a. That took quite a bit of work just to simplify the expressions inside of a square root. Now they want tangent of theta. So just before we start trying to evaluate tangent of theta, we can at least come up with the sign of tangent of theta based off of the quadrant that theta is in. Quadrant 4, we said sine's negative, cosine's positive, and if you remember, tangent, I can go ahead and start, is equal to sine divided by cosine. What I'm using here is the quotient identity for tangent. Since we divide a negative by a positive quantity, we're supposed to expect a negative quantity in return. So it's supposed to be a negative. So once I've finished everything out, or once I've evaluated this and simplified and whatever else needs to be done, we should have arrived at a negative result. So the value of sine is a fraction. I'm looking back down over here. Negative square root of 39 over 8 is what I'm going to plug in. So negative square root 39 over 8, and that's a 9, by the way. It looks like a 4. That's going to be divided by cosine of theta, which was given, 5 over 8. So then underneath, as a denominator, it's a fraction, 5 over 8. So here we have what some textbooks call a complex fraction. That's a fraction within a fraction, or a fraction that contains fractional quantities. What I see here and what I'd like for you to be able to see is just a division between two fractions. So this could be written as negative square root 39 over 8, and that's being divided by, let's write a better division sign, divided by the quantity 5/8. Now, if you remember before high school, middle grades mathematics, to divide fractions, you treat it as a multiplication problem. The left fraction stays as is, square root of 39, negative square root of 39 over 8, and you will change the operation to multiplication as long as you take the reciprocal of the right one. So the one on the right would be 5/8 changes to 8 over 5. So 8/5. So negative square root of 39 over 8 times 8 over 5. Now you'll notice that when we multiply two fractions, well, first off, when we multiply two fractions, in order to get that done, you're okay to multiply the numerators together and the denominators together, and that'll result in the new fraction that we're looking for. So you would get negative 8 square root of 39 over 8 times 5, which would be 40. But if you're already used to that computation, you can just go ahead and check first off before we actually multiply for common factors, and there's an obvious common factor of 8, which we can go ahead and cancel out before we even multiply stuff out. So we can disregard the 8s because those are common both top and bottom, and we're left with negative square root 39 over 5. And I got to fix those 4s. My 5s are pretty bad too, but the 9s need to be fixed. I think that's as far as we can go. Negative square root of 39 over 5, and that's a 5, I swear. This is the value for tangent. And I can box that. And we were expecting a negative quantity for tangent because sine was negative, cosine is positive, and when you divide the two, you get a negative answer as a result. And yeah, there we are. So that's the value of tangent theta. So we're almost done. They want the value of secant of negative theta. We applied the even-odd identity for secant, which in this case secant is even. And it's the same as if we're just looking for secant of theta. So if you remember secant of theta, I don't think we need to do any hard work for this one, like we did for these two. These took a little while. This one's pretty simple. In order to find secant, you remember that secant is the reciprocal of cosine, and that's important because they gave us cosine. So if they gave us cosine, you just take the reciprocal of cosine and you're done looking for secant. So if cosine was 5/8, secant is 8/5. And that's the value of secant. And that's it.